friend, the thing. God, what was the name of the thing again? The thing that we've been studying for the last couple of days? What's it? The definite integral. The definite integral, I think we already know what this means. Victoria, what does the definite integral mean?
It's the area bounded by the function, the x-axis, and the vertical lines, x equals a and x equals b.
Perfect. Could not have said it better myself. When I write a definite integral, it means area. Unless, of course, it's not just some basic function. What I'm actually looking at is this guy here. Nathan, do you remember what that means? What this one means?
Displacement.
This means displacement. Specifically, this is displacement from a place to a place. From where to where? A little bit from start to end. More specifically for this problem, from where to where?
Oh, A to B.
From t equals a to t equals b. But sometimes I'm going to give you guys this one to play around with, and when you see this, you're going to tell me, oh, that's not displacement, this is total distance traveled. Total distance traveled from t equals a to t equals b, right? What if I make up some function? Let's call it, oh, I don't know, you guys like doing strange things. Theta of x with respect to x, and I'm going to go from a to b, and I tell you that theta is the rate of stuff in crops per flops.
Oh, totally.
And the dx is going to be measured in flops.
Respect to flops.
So overall, it's going to be crops. Well, how much crops are changing?
Right, the definite integral, if this is a rate of stuff, right, it's a rate of how something is changing, and I'm measuring in crops per flops. I just made those units up. It's okay, I've got a master's degree. Okay? So theta of x represents the rate that stuff is happening in crops per flop, and the definite integral means it would be measured in crops, but it means, we had this conversation yesterday, and it's what you guys did in the homework. What it means is
How much the crops change by?
how much. So how much theta either increased or decreased from A to B measured in crops. Okay? Like this is kind of where we are with the definite integral. Great. It gets better. There are properties of the definite integral. By properties, I mean there are things that are always true. Things that you can do that will make your life better. And I am all about making your lives better. Even for Anthony and Roger, who have better things to do than come to calculus class today. All right. We're good? Jose?
Are we only going to work in philosophy?
No. We're going to even work in made up stuff, or those application problems you did last night, or his car values and things like that. Lots of different stuff happening. But I want to talk about properties. When I say properties, I mean something that is always true. It is really important that this gets through to all of your brains. Properties, mathematical properties, are things that are always true. If I say something and it is false even once, we don't call it a property. Okay? So, property or not a property. The absolute value of a number is positive. Think about it. Is this a property? The absolute value of a number is always positive.
Yes.
False. False. If there is even one time where this is not true, then it's not a property. Should I repeat what I said?
Oh, you said all.
I said the absolute value of a number is always positive, and you all said yes.
No.
No, because?
Because 0 is 0. So
Because 0 is 0. What does that mean?
if you plug in 0 to absolute value, it gives you 0, which is not positive. Right?
So the absolute value of 0 is 0. Is that positive?
No.
No. So that is a counterexample, right? All you need is one time where something fails and you say it's not actually a property. Maybe you put extra restrictions on it to make the property work. Okay? So, next one, let's see what you guys think about this one. Have a conversation with somebody near you. The square root of x squared is x. Have a conversation about this.
Yes.
If it is, then you have some defense of this. If it is false, you can think of a counterexample. The square root of x, the whole thing squared, is equal to x all the time.
Yes. Because
You're here! I take back all the things that I may have said that's been captured on video. You're a good guy. You're gonna give. I don't want to touch you. I want your note. Okay. So always true.
Yes.
No.
Nathan, you can think of an example where it's not true. Give me an example.
Use a negative number.
If you use a negative number. So give me your example.
-1.
Negative. Okay. Square root of -1 squared. What is that?
Undefined.
Undefined. -1. Well, let's follow your order of operations. Square root of -1 is
Undefined. Does not exist.
Wait, don't we start from the
in the
outer?
world. No, inside out. The square root of -1. Think back to algebra 2. You guys know what the square root of -1 is? It is I. And then you square the I, and you're going to get.
1.
Oh, so sad.
Oh, -1.
So sad. I squared is -1. Property or not a property? Does this always work?
Wait,
Was it?
so we're not simplifying anything.
What do you mean we're not simplifying
Do
anything?
you know how you can square root of x power 2?
But that's where you need to be careful with how you simplify. It is possible to simplify here and get x. You are using that property. The square root of a number squared will always give you the original number. Yes, property. Let's see if you guys can get this one right. The square root of x squared is equal to x. Have a conversation about it. Property or not a property? Oh, I really hope you guys get this one right.
Yeah.
The square root of x squared is equal to x. Always true? I can hear the mumbling. You're like, okay, square root of 4 squared.
No. No. Can't.
If we're going to call it a
Yes.
property, it is always true. All I need is one time, one example
-1.
where it fails, and then we don't call it a property. Anthony, -1. -1. So, tell me more, son.
-1 squared is going to equal,
Okay, so it sounds like if you're going to let x equal -1.
it would equal 1, but then square root of 1 is 1.
Okay, -1 squared is 1. The square root of 1 is 1. So we would say that this is
Not
not
a property.
a property. Not a property.
Conjecture.
No, it's not a conjecture. It's just not a property. Here's what is a property. The square root of x squared is equal to the absolute value of x. That is a property. That is always true. My -1 example, -1 squared is 1. Square root of 1 is 1, right? But on the right-hand side, you're taking the absolute value of -1 and you're getting 1. This is a property. This works all the time. Just like Mr. Link and I work all the time. There are no counterexamples. This is a property. Okay? Excellent. So what I want you guys to do is you're going to get to play around for a little bit. I'll give you about 5 minutes to try these first 4. I've got some statements. Right now I'm just going to call them statements. And I want you to decide, using your collective brilliance, are these statements properties or are they not properties? In order to show it's a property, it means that this works all of the time. To show that something is not a property, what do we need?
Counterexample.
How many?
At least 1.
At least one. In fact, let's set the bar low. If you can find one counterexample, get out. Right? One counterexample means not a property. If you want your evidence to be a sketch of a graph, feel free. If you want to use your calculator to help gather the evidence, feel free. Do whatever you need to do to make your decisions. We'll talk in 5. Anthony, I really didn't say anything bad about you at all. Nope. Sure. Is the homework file somewhere? It's okay. There's only 6 of you. If I can't keep track of the paper from 6 of you, then good job.
Oh,
Yeah.
Think it's true. Be strong, be confident. It is true, or it is not true. I think, I guess, it might be.
Didn't they tell that to you? But like, prove it.
It is true.
I didn't even know you and I were having a conversation. I thought you were talking to Anthony Victoria.
I mean,
The first one?
statement one is,
I can't talk to
I plug in a
I
different.
don't need more quality time with you.
Oh.
Okay.
I said true also.
I plug in a random equation. I put cos of x, and then I plug in 1 through 8 I put values for A, C, and B. And then I got
Oh, I'm trying with my,
Okay.
yeah.
So what I hear your argument being, and I'd love to get your thoughts on this. I picked an example. I checked it for that example. And this worked. Because of that, I'm going to say it is a property, which means it works all of the time. I would hope some part of that feels wrong to you.
Alright.
And if this is a property, then it has to be true all the time. To show something is not a property, I need one counterexample. Just one.
Oh, check out.
So what are the thoughts on this question?
I tried to make
Okay,
it.
so we're going with true. Look, Brian doesn't even bother with evidence or a counterexample. That great big box is just there for you to write the word
But the same thing, you draw a square and you cut it in half. And you add
Yeah.
one thing.
All right,
to the
so
other one.
so let's talk about this first one and what
Makes
evidence
more
means,
sense.
because Brian's evidence is the statement, this is true. Your evidence is, I found an example and it worked, therefore it has to work all the time. That doesn't work either.
So if I use multiple ones.
Oh, so of all the infinite cases that are out there, you pick 2 or 3, the probability says no.
Wait, so how would it be?
So let's give it a shot. For constants a, b, and c, a is less than c less than b, the integral from a to b of f of x dx equals the integral from a to c of f of x plus the integral from c to b. So how about if I just pick some function f of x? Do you know the name of this function? Do you know the equation?
No.
And I don't even care. This represents any function that I want. What we're saying is that here's A and here's B. Where's C?
In the middle.
Now, I want to be careful. I heard in the middle, which makes me think things like midpoint.
somewhere in between.
between.
Somewhere in between A and B. So here's where C is. Is it true that this guy here plus this guy here is the same as the integral from A to B?
Yes.
Because
Because
You're
you're just
adding
cutting
it
off
here,
like
yeah.
think about half is easy.
Okay, let's avoid words like half.
You split the area up.
I'm splitting this area up, this one continuous piece, into this area over here, and this area over here. And if I separate those two pieces, have I changed the area? No. As long as I don't throw anything away, I'm not losing any area. So if this is true, and here's a great way to go about showing it. Okay, keep going, keep going. One counterexample is good enough. What you got?
1 over x.
1 over x.
Where it's negative.
Mm-hmm.
So then the area of that, or its absolute value is times positive.
Perfect.
Positive times.
Keep going. So what do the instincts tell you about the second one?
I mean, we would probably have to use x to the next square root, like x squared or something
The
like that.
cube it. And for the use
Somewhere we
cube
have to use negatives.
Mhm.
it. Yeah.
So the key is finding a place where you're going to have some negative area.
So,
I
next
think
one.
it does make sense.
And here's the point, even if you can't come up with a particular function, like the name of the function, sketch it. So what are you guys looking for in a function that's going to say this is true or it's false?
If there's a negative,
If, to be more specific, what's a negative?
The y value.
So I need a function that goes negative. How about that? Now, if I set my endpoints as here's A and here's B,
So how will it-
you say that's not going to work like you'd say
No.
this is false?
No, I'm not saying that that's false. I'm just saying it would be better if you choose the
A little more.
vertical lines, yeah, to have some negative area.
That's the key. I want positive area and I want some negative area. Because then this guy over here on the right is smaller than or greater than this one over here? I'm sorry, and I said right, but I meant left. This guy over here, the integral from a to b of f of x dx, that says add these two areas together, right? Positive area combined with a negative area. This guy over here says treat that area that is below the x-axis.
Positive, positive.
Right, flip it up above and now treat it as positive area. So we would say that this statement is,
true.
False.
No, false.
those are the options. This statement is true or it is false.
False.
And this example says false.
Because there will be, I want to say extra area? Over x.
Well, the issue is that the area on the right, you're treating this negative area as positive area, so you're going to get a larger value
Yeah.
than what's over here. Okay? So what are the instincts telling you guys about the third one? You're not sure. So how did you make this decision of true?
Put it in my calculator.
Okay, so you tried an example, and that worked. Okay? But that's an example. If this is really true, you want to go stronger than that. You want to be able to generalize this result. I'll let you dangle for a little bit.
Wouldn't this be a linear equation? Flat?
Because your function is a constant.
Yeah.
I always want to trick you. I
Okay.
want to make you think. What do you got for that?
Oh, I see
I'm
what
not
you
sure how I
mean.
would do it, but
It's just cute.
'cause right now I proved it out in my calculator, but I'm not sure, like, in general.
one is in
Well, good. I want you to play around with that a little bit. All right. So what we know is that k is constant.
Uh-huh.
So imagine the graph. Here's y equals k. Here's b. I'm sorry, here's A.
Here's B. What's the definite integral asking you to do, Nathan? Definite integral means, what does it mean? Since day one, it's meant,
Find area.
find the area. What's that the shape of?
Rectangle.
A rectangle. You know how to find the area of a rectangle?
Yeah.
I bet you do. I bet you do know how to find the area of a rectangle. Rectangle, how do you find the area of a rectangle?
The intense width.
You take the length, how long is this?
The distance from A to B.
B minus A divided
It's-
by N.
No.
Whoa, now you're going big brain on.
Oh, B minus A.
B minus A divided by N is what you would do if I was trying to figure out how wide the rectangles are gonna be. This is one rectangle. How wide is this?
B minus A. How tall?
Okay.
Okay.
Okay, guess what?
The definite integral from A to B of a constant is just the value of that constant times the length of the interval. Okay? I will tell you right now because I want to move you guys on. This next one, this is called a linearity property. The integral from A to B of f of x plus g of x, I'm adding two functions together and I'm finding the definite integral. This is going to be a true statement. For right now, for the sake of time, I'm just going to tell you it is true because I really want to move you guys on to 5 through 8. Okay. Lot less help coming from me now. Trust your instincts. Use one another. You got 5 minutes. If it's false, one counterexample. If it's true, I want some sort of a supporting argument that you're going to use. Linearity. Okay. That's the word. I'll throw an extra L in there somewhere.
Linearly?
Like, yes, or linearity, it's
It's
linearity.
Linearly.
Linearity.
It's true because it's a constant.
Constant.
Okay, would it be a constant?
Yeah, you can still distribute it outside the material or inside. Wouldn't matter. You can just distribute it inside or out or I mean I don't know.
Completely agree.
Isn't it true because K is constant?
Constants treat you well. Constants, you will take all sorts of abuse.
Same with 6 is true.
Good. Go.
Because A to B will be a positive.
We went from B to A be a negative, but then we multiply times the negative.
It will be a positive.
There's like a specific function.
So what are you guys deciding about Stephen? Six.
Sure, true.
Remember when we talked about area, if I said if you're gonna go from A to B, but instead you go from B to A, it's the, not that it's negative, it's the opposite.
Yeah.
Right, because then you guys asked me questions about, but what if my area is below the x-axis from A to B? So it's already negative, but now I wanna go from B to A. You would take the opposite, so now you get
Alright,
positive.
alright.
Good, keep going, keep going. So what have you guys decided about statement 6?
Have been wrong.
So black one. What was your counterexample? Okay, so negative 1 over x squared plus 1. Okay, so that's your definite integral. And so here we're saying if I find the area from A to B, that is the negative of the area I would get if I go from B to A.
Yeah, that's true, because you're going from there, at the same time as going negative.
Right, this is one of the first conversations that we had about definite integrals and properties of definite integrals. If I flip the limits of integration, right, if you say, oh, find the area from A to B and you get a positive, but then I say how much area is there going from B to A, it's the opposite sign.
Yeah.
It's the same amount of area, but now it's gonna be opposite sign.
I'm trying one of them and it didn't work at all.
Which one?
I plug in S cubic and it didn't work at all.
Okay, so it sounds to me like, are you on statement 7? So it sounds like you found a counterexample. It didn't work at all. Okay, so you found the area from -5 to 5, and then you tried doubling the area from 0 to 5. All right.
Sign right.
What did you get? What did you decide on the 8th one?
Oh, it's true.
Why?
Because they're even functions because they're both end up at the same place.
Okay, but even function means something special. Even function
They're
means
symmetrical.
It's symmetrical with respect to the y-axis, right? That's where I take out my samurai sword and I chop it down the middle, and what I get on this side is a mirror image of what's over here.
So it's double.
So if you happen to have a even function, you do get this property. You can say, let me just find the area from 0 to A and double it, and be done. But it is not something that works in general.
That's true.
All right, so let's pull this together before you guys get to play with this a little bit more. All right, so going back to statement number 1. Wow, perfect timing. If only Tarek was here. All right, statement number 1, false. I'm sorry, true. Whew, good thing he's not here. Mr. Link, don't tell him. Okay, so statement number 1 is true. Statement number 2, we decided false. Statement number 3, we said true. And statement number 4, true. That's that linearity property. Statement number 5 allows you to pull a constant out in front of the definite integral. Constants are our friends. We can abuse the heck out of constants and they still come on over to play. So statement 5 is true. Statement 6, true. Statement 7, way false. But statement 8, if you have an even function means y-axis symmetry. What I have on the left of the y-axis, what I have on the right of the y-axis, these are mirror images. This is going to have to be true. Pretty good? All right, we are creeping forward. It might really feel like we're creeping slowly, but we are moving forward to a day where we're going to deal with the indefinite integral. What I want to do is we're going to play around with these a little bit more. I want to look at, we're going to do number 4 together, and I'll give you guys some time to play around with this. So I'm going to tell you that the integral from 0 to 1 of f of x dx is equal to, what is that, 4/3? And that the definite integral from 1 to 2 of f of x dx is equal to 7/3. And finally, the integral from 0 to 3 of f of x dx is equal to 7. At no point have I given you a graph of the function. At no point have I told you what the function is. Sad news, friends. Sad news, friends. Calculator not going to help you. You don't actually have a function that you can play around with. So you might as well put the cover on that calculator. It's not going to do you any good.
I just come home with a question right now.
All right, but here are the things that I know. I know that the integral from 0 to 1 of f of x dx is 4/3, and the integral from 1 to 2 of f of x dx is equal to 7/3.
Oh, I see now.
I want to know, let's do an easy one. Let's do 1 together. How am I going to find the integral from 0 to 2? Let's see, 1 out of 6, 2 out of 6, 3 out of 6. I want the integral from 0 to 2. Brian, what are your thoughts here?
I was gonna add the definite integral of 0 to 1 and 1 to 2.
And is that legal?
Yes.
Yeah.
Why?
We just proved it.
We proved it. I don't remember actually doing a proof.
They told us.
Oh, they told you. Don't even know who they are.
Should be
Statement
told.
1.
From an area standpoint, think area. Is the area from 0 to 1, when I add it to the area from 1 to 2, the same as saying what's the area from 0 to 2? Does that make sense? I hope it makes sense. So the integral from 0 to 1 is going to be 4/3.
the integral from 1 to 2 is going to be 7/3, so in total, we get 11/3. Lucio especially, hello. I didn't even get a chance to see what you wrote on your paper. Notation is going to be important here. Whenever you are writing definite integrals, there will be a starting value, there will be an ending value. Every integral ends in a dx or a dt. We're not going to start abusing our calculus notation yet. Okay, we're going to be very, very good. Just like there once was a day where limits were really important and then we started abusing them, that'll come later. Abuse comes later. All right, one more to do together as a group. Number 4, have a conversation with somebody near you. What's your strategy? Do you see any helpful properties?
Zero, three.
Are you making a big reason?
Yes. Maybe.
I think that is a very good idea.
To make an equation.
Yeah, like give yourself like a little visual.
Yeah.
It's a good idea.
Or the constant just take off.
One problem.
Number 4. Anybody see any property that might be helpful?
You don't have to worry about it.
So I want to avoid plugging in because I don't really have a function to plug into. What I know, Anthony, I have area statements that I know for sure. And I want to find the definite integral of 3 times f of x plus 5. One of the properties is that that integral behaves nicely over addition, meaning instead of finding the area of the sum, find the integral from 0 to 2 of 3 times f of x dx plus the integral from 0 to 2 of 5 dx. I'm breaking the integrand up into 2 different functions. The reason that I'm doing that, there's some more nice properties. Anybody see a nice property?
That one property you said, the linear.
The linearity property? What do you mean by that?
Because there's 2. Technically, the 5 is a function.
The 5 is its own function, and the 3 times f of x is another function. I've kind of used that linearity property to go from here to breaking it up as 2 different integrals. Anybody know the definite integral from 0 to 2 of 5 with respect to x without using your calculators?
10.
55 over 3, 10. Think about what I'm asking you here. Go back to the definition of a definite integral. This means how much area is there bounded by what are the 4 bounds?
X-axis.
The x-axis.
Vertical line.
F of x, but you're saying f of x, but you're not looking at the problem.
Is it 5?
What's f of x?
5.
The line 5. How much area is bounded by the x-axis, y equals 5, and
0, x
Vertical line.
equals 0. and
x equals 0 and x equals 2. If only I had 4 arms. X-axis, y equals 5,
2 times 5.
x equals 0 and x equals 2. And you said what?
2 times 5.
2 times 5. I thought you said 55. Oh my God. Right, this is that property that said it's your constant, so it's 5 times the difference between your limits of integration, so it's going to be 10. Right, having that visual is a really good thing. We're talking about a straight line here. Now, the problem is, over here, I want the definite integral from 0 to 2 of 3 times f of x dx. That 3 is messing it up. I don't know stuff about the function 3 times f of x, but I know something nice. What do you know about constants? You can factor that constant out in front. Constants are your friends. So you can say it's 3 times the definite integral from 0 to 2 of f of x dx plus that answer over there. The integral of f of x dx from 0 to 2, I think we know what that answer is.
3.
Right, we've already figured that out. So this is just 3 times 11 over 3 plus 10, which I think is 21.
21.
Okay? I care greatly about your ability to use the properties to make your lives better. So some of what you can do with the remaining 6, in the event that you finish early, and I think some of you guys will, I'll move you on over to the homework. But
take some time, get used to writing that definite integral, the dx, the limits of integration. I promise your hand will not break. This is good for you. Keep going.
I just broke it.
Rework if I do this. Rework if I do this. I do this minus
That.
this.
Yeah, that's okay.
So what are you thinking?
Subtracting. So it's 1 to the 3 right now. So I do this
Mm-hmm.
minus this one.
Okay. And does that just kind of make sense?
Yeah.
Right, it's not a property that we've really talked about. But you're saying I've got the area from 0 to 3. I know this much. I figured out the area from 0 to 2. And what I want is the area from 2 to 3. Use a subtraction
Trust.
property. Good. Trust your instincts.
This times 3, you know?
What's up? Okay, so then you put 0 to 3 minus, oh my god, in parentheses 2? Nice job. Perfect. Love. Love, love, love. Yes, sir.
Well, I got to know.
Is number 7
Yeah.
36? So you break
Okay.
it up as 2, 6 times the integral from 0 to 3 f of x plus the integral from 0 to 3. Oh, okay, alright. Being clever. So then that's integral from 0 to 3. Did we decide the integral from 0 to 3 is 7? Yep. Nice job. You really are smarter than you look. Total compliment for you, JP. I would love to check the history. So integral from 2 to 3 is 10/3, I agree. The integral from 1 to 3, so you found the integral from 0 to 3, then you subtracted the integral from 0 to 1, so that's 7 minus 4/3, that's 11/3. Wait, 7?
7. Oh, wait.
Oh wait, so you said...
Oh, wait, I messed it up. Yeah.
How you doing? 7 minus 7/3. Okay, so you're switching back to, I'm not going to simplify mode. Okay, so the integral from 0 to 3 is 7, minus the integral from 0 to 2 is 11/3, because we figured that out over here. Okay, good, that's fine. On the multiple choice though, clearly you would simplify. And if you cannot subtract 7 and 11/3, don't judge me. But thank you for writing your limits of integration. Thank you for writing the dx. The place where you're going to be allowed a little bit of abuse of the notation is forgetting to write the dx, or the dt, or the whatever. But right now, let's just get used to writing. If you don't write the limits of integration, you're doomed, because they are a big part of the story.
Yeah.
The dx is one of those things that we sometimes just assume what the variable is. You're like, oh, it's v of t, dt, clearly. So if you forget the dt, it's usually okay. But when you move into Calc 2 and beyond, and now it's like
Would
multivariable
6 be
calculus, the d stuff's important. Is number 87? No. No, for real, for real. Wait a second. Okay, you're right, but for the wrong reason. Yes, the answer is 7. Yes, the answer is 7. It's totally abusing the notation. It's, you have the right number, but it's like a random guess. You got lucky here. I'm really
No.
interested in your getting good math here.
Wait, you get the fix it. found the
But how can you possibly tell me what the integral from 1 to 4 of f of x is?
Yeah, so negative.
okay, because you know how they have a chain, the width,
Uh-huh,
Yep.
and then you keep adding by one,
yeah.
and then so I just added 10 over 3 plus 1 and got 13 over 3. And that's the boundary from 3 to 4. So I just added 1 to 4.
Okay, now we're getting closer. F of x minus 1. What is that?
Oh, I was supposed to plug that in.
Well, what does that do to the original function? If I said work with f of x minus 1, what does that mean?
So I should check the.
Moves it one space. So
I moved it one space to,
right there.
so you're moving the function. So if you're thinking about in your picture, Jose,
You've drawn yourself a picture and you say, here's f of x. Here is the area from 0 to 3, and we know that to be 7.
what am I asking for?
Then you go from 1 to 4.
1 to 4, but of a different function.
Oh, x minus 1.
F of x minus 1. Inside the parentheses, that x minus 1, that does something to this function.
Oh, it moves more to the left.
Oh, can it just be 0 to 3?
Well,
instead?
hold on a second. Moves it which way?
That, so we,
That's the problem.
wouldn't you be finding the integrals from 0 to 3?
F of x minus 1, if that subtraction is happening inside the parentheses, you move everything right one space.
So
So take this whole graph and shift it one space to the right.
If I could draw it well,
It would look something like that.
the piece that was from 0 to 3
No.
is now the piece that is from 1 to 4.
So it would be the same.
And so what's that area?
7.
7. Because I took that whole graph that you sketched for me and shifted it a space over to the right. That's the big piece here.
that's a good answer.
Yes, you did, and I will make sure that the next time I ask you a question like this, I make it so that your method fails. Anthony,
Help me with number 5.
I would love to help you with number 5. If you are done with all 8, like you've got this on lock, the problem set this weekend is this one over here. It's all word problems. It is all calculator active. I will tell you that when you look at question number 1, you might be tempted to say, I can't do this. He didn't give me the function. I don't have something to type into the calculator. It is at that point that you will read the note that says, since you don't have an equation or any other information about R of t, you're not going to be able to determine exact answers. I'm just interested in your setups at this point. Hi, Roger. Okay. So, question number 1, there is no actual calculations for you to do. It is about setup. But then you've got a nice physics problem and some more word problems. You're going to want to be careful with number 5. Every year, everybody always messes that one up because they don't read things carefully. Be careful. All right, but you don't get to start on that until I've checked your answers. You want to help number 5?
Yeah, can you try to check this?
I would love to. So you pulled out the form.
I did actually, it was actually kind of
Good. So integral from 1 to 2 plus the integral from 2 to 3, 7/3 plus, okay, you found the 10/3 up here, love. This one we did together. This guy here, you get an even function, so the integral from -3 to 0 plus the integral from 0 to 3. Now be careful, because now we're getting sloppy here.
Oh, the f of x is
I need an f of x, I'm gonna get
Yeah,
dx.
check this one.
Yeah, so it's, I agree, 14.
No, this one.
And that one. So we're gonna split it up into 2, you're gonna factor out the 6. Looks good to me, looks good to me. Okay, friends over here, we good? So number 5 is gonna be 0, why?
This time
Right, whatever is happening from 0 to 3, like the negative version of that is happening from -3 to 0, so they're gonna cancel each other out.
X.
And then if it's an
The
even
y values
function
will be
instead,
opposite.
then what is happening from 0 to 3, you have the reflection over here, so whatever area is here, same matching area.
Y values.
Anthony, Nathan. You get 21 For 6?
How you got 21 for 6?
I didn't get 21 for 6. I got 21 for 4 and it didn't fit in the box. You're pulling a Roger on me, aren't you? What I like about these properties of decorative minerals is just kind of makes you start to think about the decorative mineral a little bit more. To really like emphasizing that area. So this is normally something I might do in like a half-day lesson, which is why we wanted ending a little bit early. And that's what I wanted you guys to go and start with this weekend. Good news, there are more properties coming on Monday. And because I'm such a giver, where are my folks that took AP Stats last year?
Roger.
Roger took it and Victoria took it.
Didn't want me
He didn't want you in there? Don't blame him. So I'm going to dig into my AP Stats knowledge bank. I'm thinking about the normal curve. I'm thinking about Z-scores. I'm thinking about all that stuff. And maybe doing a little bit of stuff like that with definite interval on Monday. So excited. So excited. Huh? Mr. Selholzer taught stats.
Way.
All right. So if I've already checked with all 8, then you are working on the homework. What can I do for you, son? Okay. You just wanted some extra love in your life? I think we can turn left.
The graph.